one is maintain a list, have an Excel spreadsheet, maintain a list, and try to maintain as much as you can. Second is if you are working with multiple vendors, create some kind of rule. This vendor will use this range, that vendor will use that range, or these buildings will use this range, and that building will use that range. And the third, but definitely not one to ignore, is check for the address that you're about to use to make sure that it's free before using it, right? Do a whois to that device ID, do a ping for that IP address. And of course, I should mention that use software like Wireshark or Optigo VN to verify for duplicate address. Excellent, incredible, good question. It's a very tough answer because it depends a lot. What I mean by that, if you're looking at a small device that's running like an ARM7 processor with 64 meg of memory, it's going to have a much lower threshold for the amount of packet it can process per second compared to a big server. If you're looking at a smaller device, you probably want to keep it below 10 packets per second. It sounds very little, but that's 600 packets per minute. The second bucket, I would call that mid-range device. You can probably do 20 to 50 packets per second, not sustained 50 packets per second, but peaking around there, you can probably deal with it. And then there's the big servers, right? Where you install your BMS software on it, it's running a VM on it, that can support a lot more. But even then, I would still suggest to try to keep the amount of traffic to below 100 packets per second. Note that in a lot of modern managed switches, there is by default a cap of 100 packets per second of broadcast traffic. So if you go into a system that is very, very busy, your network might naturally be cutting off some of this excessive broadcast traffic, whether you expect it or not. I should mention that MSTP devices are a very different class. We really want to keep that as low as possible. Even 2 to 5 sustained packets per second is a lot in MSTP, especially when you have a lot of devices on that chain. So to sum up, if it's an IP-based device, think of it as those 3 categories. The small devices, keep it 10 packets per second or lower. That mid-range device, 20, 25, 50 packets per second. And then the large servers, you can do a lot more, but even then I would try to keep it below 100 packets per second. And then there's the non-IP devices, the serial devices, the BACnet MSTP devices. Those ones really try to keep it 1 or 2 packets per second of sustained traffic. But most importantly is all these are guidelines. If you really want to know, you have to look at, is the device performing as expected? Is it dropping packets? Is it resetting itself? Is it slowing down? And there are ways to measure that. And of course, if you're not already using Optigo VN, we do look for those things. I do often get asked, how forgiving should I be, or should my system be, to determine if a device is online or failing offline? It's a tough question, but I will say in general, I find that this industry, we are too forgiving. We are too accepting of systems that are not operating properly. What I mean by that is that when we look at the greater internet, it is normal for packets to be dropped. But when we look at a building automation system on a local network, we really shouldn't be that forgiving. If it is dropping packet, if it has a large variance, that should be addressed. We really should be failing a device if it fails to respond twice, right? Giving it 6 times and trying it with seconds in between, even if it comes back, to me, that's a very strong indicator that there's an issue in the system. I would suggest that when we look at building automation, when we look at our local networks, the ping time should be very low. The number of times it fails to respond should be extremely low. I'm talking about sub 1%. And if it is above that, I would really take a moment and figure out where the bottlenecks are, what is changing the system that's causing these failures. Great question. BACnet models a system as a system of devices, every device having objects and every object having properties. It sounds really, really fancy, but just think of it as us as a human. Every person is a person. We have different quote unquote objects, my left arm, my right arm, and then there's different properties. What's the length of my arm? What I do with it? Is it online or offline? Of course. So just think of it this way. In BACnet, there's a collection of devices. Every device has a number of objects, and every object has a set of properties. You can read what's the current status, is it on or off, what's the present value, what threshold am I setting on it. Finally, services can be just thought of messages. I can read, I can write, I can subscribe to a change of value, I can reset the devices. Services are just different messages that BACnet standard provides that everyone using BACnet can use. We are doing this series of short videos to answer any questions you may have. If you have questions around BACnet systems, how BACnet works on OT networks, how IT and OT works in combination, send in your questions and we'll get to it. Thank you.